You're listening to a podcast from the South China Morning Post.
This year, 2021, has seen not one, but 4 historic achievements for China's space program. In January, the Chang'e space rover landed back on Earth carrying rocks collected for the first time from the far side of the moon. In February, the Tianwen spacecraft became the first Chinese vehicle to enter the orbit of Mars. In May, the Tianwen spacecraft delivered the Zhurong land vehicle to the surface of Mars. And just last week, 3 Chinese astronauts arrived at the Tianhe space module orbiting the Earth. They opened the hatches, turned on the lights and life support systems, and began working on building China's first space station orbiting planet Earth. Ground control to Tiangong.
我们乘组已进入
This is mission leader Nie Haisheng.
我们的太空家园天号一
He's saying, "We thank all Chinese people for their support. We thank the scientific and technological workers for their hard work. We salute you." The weird thing is, they weren't the first astronauts to radio back to Earth from Tiangong.
Houston in the blind. This is mission specialist Ryan Stone reporting from the Shenzhou. I'm about to undock from Tiangong.
Okay, that only happened in the movies. That's actor Sandra Bullock in the movie Gravity, which came out 8 years ago. It's a pretty good example of how something once considered science fiction not very long ago is now a science reality. You're gonna hear something in this episode that maybe even 5 years ago would sound like science fiction. You're gonna hear about a satellite system being launched to operate self-driving cars. You're gonna hear about plans for a nuclear-powered moon base operated by robots. And you're gonna hear the words, Hong Kong Space Program. Prepare for blast off, because the Inside China podcast is once again headed into space. This is Mimi Lau. As we discussed in our previous episode on the Tianwen Mars mission back in February, the notion of a 20th century-style space race between China and the US ignores the reality of what's actually happening right now. We really are witnessing the dawn of the international space industry. And that's why you're going to hear once again from our new friend Andrew Jones, a British journalist working from home in Finland.
Well, right now I am sitting in my sauna, which is the quietest place in the house, given that it's school holidays.
And an Australian professor of astronomy and astrophysics in Hong Kong.
My name is Quentin Parker. I'm an Australian from Sydney and Coonabarabran, originally from the UK, who came to the University of Hong Kong in 2015. But now, for the last 3 years, I've been director of the Laboratory for Space Research.
But let's start with a brief history behind the moment where 3 astronauts docked their capsule with China's first space station last week. And what exactly we're going to call this thing they're now floating around in.
What we saw in late April was the launch of the first module of what I call the Chinese space station. And that's called Tianhe, which is like harmony of the heavens or heavenly harmony. So this module is about 22 metric tons. It contains the main living quarters for the astronauts while they'll be on this space station. And this Tianhe module will be joined by 2 experiment modules in 2022. And those 3 modules together will be the Chinese space station. It's sometimes called the Tiangong complex or Tiangong space station. I don't use that because it's a little bit confusing, because as kind of practice stepping stones to these large modules we're seeing launched now, China in, I think it was 2011 and 2016, they launched Tiangong 1 and Tiangong 2, which were 2 small space labs. So they were kind of just testing out the life support systems, rendezvous and docking technologies that you need to do, refueling, that kind of thing that you'll need for the proper space station. So just to avoid confusion, I just say Chinese space station.
And there's something that's sort of been missing from the headlines about the space station and why it means so much to China. One of the main reasons why China built its own space station goes back over 20 years ago, when the USA, Russia, Japan, Canada, and the EU all joined forces to build and launch the ISS, the International Space Station.
China was very keen to be part of the International Space Station, as you know, but they were snubbed, I have to say principally, as everybody knows, by America to prevent Chinese collaboration on the International Space Station for reasons which are now looking a little silly 10 or so years later. China has actually opened up its own space station to international collaboration. It was only said yesterday by, I think, one of the deputy directors of their program that they're looking even to international astronauts being able to go on missions to that space station. And so I think this is fantastic, and it's a way to move forward. Going back to the International Space Station and the fact that China wasn't allowed to participate, yes, I believe strongly this did spur China on to develop its own capacity. And the effect of that is that you've now got a brand new, high quality, cutting edge international space station being built by the Chinese basically on their own. They developed their own technologies. They've actually surpassed the West in terms of its ion drive technologies. They've worked on it secretly for decades and have now delivered it. And so I think that China doesn't need to prove itself to anyone anymore. It's already put its money where its mouth is.
So now China's space station has started its 10-year mission. What happens next?
So the 3 astronauts commanded by Nie Haisheng, they will stay on Tianhe for 3 months. And what they're going to be doing is testing the so-called regenerative life support system. So when you go into space, you pretty much have to take everything that you need with you or send up cargo ships. So there's already the Tianzhou 2 cargo spaceship there, and that's brought supplies and propellant which will keep the mission going for as long as the astronauts are on board. And the thing is with the regenerative life support system is that, okay, so you're drinking and eating, and then there's the waste side of things. So basically turning like the 5 liters of urine that the astronauts are producing over a certain period of time and changing that back into 4 liters of water, which they can use again. So that's kind of a step up from what China was doing with these Tiangong space labs in the last decade. So they'll be testing those things. There's a 10-meter long robotic arm on the outside. They'll be testing that because that will be used to help with the docking and construction of the space station when the other 2 modules come. Also, they'll be doing some extravehicular activities or spacewalks. So they'll do at least a couple of those to go and check things are ready on the outside of the spacecraft and get things moving on that side. So they'll be up there for 3 months.
In September, there's going to be another rocket launched from China. This one will bring cargo, supplies and fuel, and then a serious job of building the full space station begins.
They have 2 main science labs. One's called Wentian and the other's called Mengtian. I'm not sure if I've pronounced that properly. And that's attached to the main Tianhe module, which is a core module that went up first. Then a cargo module went up next, and now they sent up the crew capsule yesterday. And then later the science labs will go up. Now, these science labs are designed to undertake all sorts of experiments. There's like 50 docking ports on the outside, and they've got space for many on the inside in various modules. In fact, the University of Hong Kong Laboratory of Space Research is associated with one of these modules, the so-called high-energy radiation detector.
And this is the moment that you and I both find out Hong Kong has a space program. And back in 2015, the University of Hong Kong collaborated with Nanjing University to launch a satellite carrying an X-ray telescope to search for dark matter. When this new space station is built, it's going to be open for research, and it's not just for scientists based in Chinese universities.
This is a science mission. It's not a commercial satellite. It's a mission purely for science. They want to show their magnanimity, if you will, to the world community of scientists. There's no American mission experiments here, but you've got Spain, Peru, Belgium, Netherlands, France, Norway, Saudi Arabia, Japan, Mexico, Kenya, Italy, India, Russia, Germany, Poland, Switzerland. I mean, these are major countries. And they're all part of the science mission of the Chinese space station.
So it's a Chinese space station with international characteristics. Interesting. There's something else about this space station that's got Professor Parker very excited.
As an astronomer, there's quite a few exciting astronomy experiments that are up there. And don't forget, the Chinese are going to be associating with this space station a Hubble-type space telescope. The Chinese space telescope will be 2 meters, mirror, just a bit like the HST, but it'll have a field of view from its billion-pixel gigacamera, 300 times the field of view of the Hubble Space Telescope. So this is going to be like the Space Telescope on steroids. It's going to be a massive new science facility, and I'll be keen to get data from it. I'll be keen to use it. I'm a wide-field astronomer. It's a wide-field telescope looking at a large area of sky at once, and so I'm very, very interested. So that's a very, very exciting development for me, not just in the fact it's going to be another above Earth's atmosphere space facility, but this field of view is game-changing.
There is a very good reason why he's been a bit excited about this. Professor Parker was in charge of a 10-year study that used the Hubble telescope to look for a planetary nebula, the glowing clouds of gas that are ejected from red giant stars. In fact,
I've discovered more than any person alive. Don't name them after myself, though, because I'm not that egotistical.
From his work, Professor Parker and his team at the University of Hong Kong created an international research platform in conjunction with universities in Sydney and Strasbourg, currently being used by more than 400 researchers in 32 countries across the world. And just 2 days after we recorded our interview with Professor Parker, this happened.
After suffering a software glitch, NASA's Hubble Space Telescope has gone into what's called safe mode, in which it is no longer functioning as usual.
Then, when they tried to switch on one of the backups, it turned on, but it was acting strangely, and it appeared to be malfunctioning.
The Hubble telescope's computer is in safe mode, and while the team at NASA try and figure out how to press Control-Alt-Delete on a computer from the early 1990s, that's orbiting roughly 550 kilometers above the Earth, the global community of astronomers are waiting for China's version of a space telescope to be launched.
This is an absolutely massive telescope and camera. The idea is that in the 10 years that it's planned to be in operation, it will, while this is kind of doing something which Hubble did in a sense, it will, it's an update, and it will be contributing a lot more in terms of our ability to survey the sky. And the other thing is that this will be like flying by itself in orbit. However, it'll be in a similar orbit to the Chinese space station. So if there is a problem with the space telescope, as we have had with Hubble over the years, the telescope will be able to dock with the space station, and then they will be able to carry out repairs or maintenance or even upgrades over time. So that's a very interesting approach to launching, this major space telescope. So maybe there's, some lessons from Hubble there.
Just in case you don't remember what happened in the 1990s, this is not the first time there's been a problem with the Hubble telescope.
I think we saw a few shuttle missions back in the day going up to Hubble to fix various issues. I think in the very beginning there was a problem with the mirror itself, and they had to go up and basically save the telescope. So yeah, that's going to be a major addition to the space station and to China's and the international astronomy community. So that's something that's going to be really interesting to watch, and seeing the images from those will be quite amazing. I think that's planned to launch around 2024.
2024. That's in 3 years' time. But let me take you back to the present. Just 1 day before those Chinese astronauts blasted off, there was an official announcement from a conference in Russia. It was a timeline laying out the plans for China and Russia to work together and build a base on the moon. And the plan starts in the year 2021. On Wednesday, June 16th, Russia and China officially unveiled their plans to build something called the International Lunar Research Station, or in the words of a very excited podcast producer, a moon base. Any Pink Floyd fans listening right now might be happy to know it all started with a visit to the dark side of the moon and China's lunar rover called the Chang'e.
China's early Chang'e missions, so the orbiters and landers and rovers, have been successful. And at the same time as those launches, there was the kind of discovery internationally that there may be things like water ice trapped in craters of the South Pole, which never see sunlight. And that would mean that it would make it a lot easier to send astronauts to the moon and stay there and be able to use resources from locally rather than take everything with you.
And by locally, the plan was perhaps China could send a 3D printer to the moon and use the lunar soil to build structures. But that was way back in 2017. It's difficult to remember everything that happened back then, but one thing that happened was that Donald Trump announced the US was once again going to send astronauts to the moon and launch the Artemis program.
This is a giant step toward that inspiring future and toward reclaiming America's proud destiny in space. And space has so much to do with so many other applications, including a military application. So we are the leader, and we're going to stay the leader, and we're going to increase it manyfold.
And that, of course, led to a response from China.
China looked at building something a bit more sustainable and larger in scale. And they came up with the idea of an international lunar research station, which sounds a lot like the European Space Agency's Moon Village idea, which came out in 2016. So there was all these different concepts for going to the moon and staying there and so on, and what you can do on the moon. And what we've seen in recent years, particularly after the invasion of Ukraine and annexing of Crimea, is relations between the United States and Russia becoming very sour. And that's also spread into space to some extent. So Russia's now thinking about leaving the International Space Station project and also looking at what it wants to do next. So rather than join NASA's Artemis project, Russia seems to be looking now to have joined China in promoting this International Lunar Research Station. So what is an International Lunar Research Station?
Is it a moon base?
I think particularly if, you don't follow space very much and, you've probably seen sci-fi and stuff, you're thinking of, some kind of big moon base.
Yes, a moon base.
It's not that simple, at least not early on. So it's kind of Russia has a few lunar landers and orbiters planned. China had its new Chang'e 7 and Chang'e 8 missions planned, which they would have landers and rovers and relay satellites and small little hopper spacecraft to check out some of these permanently shadowed craters. So it's kind of a rebranding of these missions and saying, well, if we join all this together and combine the science goals and some of the technology tests, we're going to call this kind of a research station.
Based on the moon, it's a moon base.
And what we're going to do is carry out reconnaissance and find out what resources are there, how easy are they to extract and to use, and then from there build something more permanent, so more robotic structures which would include, say, something which can generate energy, whether that's going to be nuclear powered or solar powered or something like this, communications arrays, and basically build up a platform that in the 2030s could be used to host astronauts.
Can we backtrack a bit? Did he just say a research facility on the moon using robotic structure utilizing nuclear energy? Did he just describe a nuclear-powered moon base operated by robots?
I mean, that works. You can spin it like that, yeah. China released this roadmap, and the early missions are detailed. And there's a few kind of renders, a few pictures of what the first actual so-called ILRS missions starting in the early 2030s would look like. But they haven't given details like the actual power source. Now, China's interested in nuclear power for space exploration, but it doesn't have much experience in this realm. So
China doesn't have much experience, but the US does. In fact, is used something called a radioisotope thermoelectric generator on more than a dozen missions, including the Curiosity Mars rover.
China needed, for its China 4 mission, to get a radioisotope thermoelectric generator from Russia. So the kind of this power source and heat source which keeps the mission going in the lunar night, which gets as cold as about minus 180. So, if you don't have something to keep it warm and running, then, you lose the mission. So that needed to come from Russia. So that's actually one interesting aspect of this China-Russia collaboration, because people are asking that Russia's space program seems to be stumbling a bit. The funding is going down. They're losing a lot of the expertise which they've had over the decades and isn't being replaced, apparently. But something like this would be very valuable. But we don't know what they have planned.
Okay, so let's not rush to conclusions on how China's going to power its moon base. And just a note, if you've listened to our podcast on China's new breed of science fiction writers, it's a reminder that the first science fiction novel written in China was called Lunar Colony, and it was published in 1904. And the Beijing government does love its historical milestones. So let's recap. Right now, China has 3 major space missions all happening at once. It's got a lander and a rover on the dark side of the moon. It's got a lander and a rover on Mars. And now, it's got astronauts living on its brand new space station. There's more to come, but it's not coming from the Beijing government. The trends of the US space industry are echoing in China. And by that, I mean lately, any headlines about the American space industry are dominated by one newly divorced billionaire who wants to take his brother on a rocket ride, as well as the SpaceX program.
And that's basically one kind of billionaire, one entrepreneur, basically wanting to go to the moon and to Mars and all this kind of stuff and trying to make it happen with quite remarkable engineering. So this is something that China noted in the last decade, and in 2014 opened up its space sector to some degree to private capital. And this year I think we've only seen one commercial company launch, and that was a failure. But what we could see in the next few months is a company called Landspace could actually make the first attempt to launch a rocket which is powered by liquid methane and liquid oxygen. So that would be something which will probably be overlooked given everything else going on, but would be a big deal. There's been, I think, 4 companies which have tried launching rockets so far in China, which are, to some extent separate from the main kind of state-owned industry. Also, China's looking to build its own so-called mega constellation, which means sending up thousands of satellites into low Earth orbits to provide broadband connectivity. So that's something that Amazon is doing, that SpaceX is doing, and that's actually a big worry in terms of space debris and potential collisions between satellites. Yeah, it's not all astronauts kind of spinning around in microgravity. China also has its own answer to GPS, and while we all use GPS every day for various services, these things can be used for guiding missiles, for tracking, for coordinating your troops around the globe. So that's something which is a big game changer in terms of Chinese imprint on the world and its capabilities going forward.
Back in our February podcast, Andrew gave us an in-depth overview of just how many Chinese companies are getting involved in the space industry. From companies building rocket ships to satellite companies and manufacturers of all the bits needed to make those things work properly. And while there's no Chinese equivalent of Jeff Bezos or Elon Musk pouring their money into space missions, there is one major company that is branching out beyond Earth. And that's one of China's biggest car companies, Geely.
They've set up satellite manufacturing centers and also setting up a head of operations, I think it was in Guangzhou. And so that's a car company, and they are looking at launching hundreds of satellites, which would kind of enhance the signals that you get from Beidou or GPS to, instead of providing like meter level accuracy for positioning, down to the centimeter level. And they would use those satellites for that, but also for kind of data transmission. And that would be used for autonomous driving. So that's another kind of indication of just how fast China's space industry is growing, and in different directions.
So let's bring it back to Earth. Let's bring it back to Hong Kong and Professor Quinton Parker. And he's got something to say about this new era we are living in.
You mentioned about America and China. Look, I don't like this adversarial thing. Oh, we're going into another space race. It's not like the Cold War and Russia and America with global nuclear destruction just around the corner, potentially. We're in a different world now, I believe. Sorry, but, major spacefaring nations, it's not just America. It's America, it's Russia, it's the Europeans with their massive Ariane program and all the countries involved in that. Huge expertise in Europe, including in the UK. And you've got Japan with its program. You've got India emerging as a major spacefaring nation as well, with their own rocket capacities, etc., sending satellites to Mars, etc. And so you've got quite an infrastructure, a community of spacefaring nations. Now, I would say the strongest spacefaring nations are now America, Russia, Europe, and China. I'm putting China right up there now. And that, where the pecking order is, that's going to change. And then China's going to move up even further in the next few years. It's self-evident from their plans. When China says it's going to do something planning, they actually tend to do it.
And that's all for this episode of Inside China. You can follow all the updates on China's space station, its Mars mission and its Moon mission on scmp.com, including the excellent interactives and animations explaining what is happening up there. My name is Mimi Lau. You can find me on Twitter at GZMimi. Thank you so much for listening, and wherever you are, stay safe, get your vaccinations, and see you soon.
For more podcasts from the South China Morning Post, head to scmp.com, where you can hear more about technology, trade, culture, and society.